Hello, hello. So welcome back to my channel in 2024 July. So on 7th of July we will be learning Kubernetes in 2024 in a very fast mode 1 hour. So guys, let's buckle up your belts and start for the journey roller coaster ride. So yeah, let's start what is Kubernetes and we will brush up or read all the concepts within 1 hour. Let's start at 10:41 a.m. So we will follow this book which I have read multiple times and it has helped me in many interviews and actual practical applications. So why do we there's a most typical question that is asked in interview, why do we need Kubernetes? So we need Kubernetes for self-healing, service discovery, scaling, deployment, orchestration, storage management, cluster optimization, batch workloads. Self-healing Kubernetes based controller ensure that containers are restarted when they fail and rescheduled when the nodes are running on fail. User defined health checks. So many times if you see Spring Boot APIs, there's a liveliness check, 200 check, 302 check. So Kubernetes API ping these Spring Boot microservices API to check to understand whether these containers are working or not. Service discovery. So many times if you want to know what are the different services available in your system or cluster, so earlier there was Eureka service from Spring Boot stack, but now Kubernetes itself is providing you service discovery. You can call service discovery using IP address or some namespace, and there is a standard applications can get DNS load balancing. Scaling Kubernetes will be having horizontally scalable and down scaling facilities as well. You can tell how many pods you want, what is the fashion where the request would be going round robin or load balancing kind of things. Deployment orchestration. So if you want a blue green deployment, canary deployment, you can use deployment orchestration. You can divide the traffic 1% to the new changes and 98% to the existing changes, and if the build is successful and running for 1 hour, you can completely divert the traffic. Storage management. Kubernetes ability to support managing the underlying storage such as elastic block storage, mounted tools, NFS. Using Kubernetes you can also mount Helm chart based ephemeral storage. Cluster optimization. For storage in Kubernetes you can use etcd. Cluster optimization. Scheduler assign your workloads to machine based on their requirements, align for better utilization. Batch workloads. Long running workloads can also manage batch jobs such as continuous integration, batch processing, and cron jobs. So the root of containers, why do we need containers? So Kubernetes and Docker comes in between the host operating system and virtual machines. So virtual machines like VirtualBox, Oracle, VMware, etc. are mounted as software inside an OS, which somebody has to log in and further deploy their applications. But Kubernetes itself can use the kernel of the host machine and can give a separation sense of environment where your process runs are in isolation or sandbox environment. So it is in between the VirtualBox and the host operating system. So it has been chroot is most commonly sandbox untrusted process, shell process for shared FTP SFTP processes. Chroot is in fact the very simple isolation tool that has been provided. So once you install any Unix operating system, you can see some chroot commands, or in case of recovery. What is C groups? Control groups provide an interface for controlling one or more group of processes, hence the name. They allow for control of several aspects of the group. Uses of resources. Resource utilization can be controlled using a limit. For example, by limiting. C groups also allows priorities to be set, give process a greater or less share of time-bound resources such as CPU. So Kubernetes will be having nodes, containers, pods. So nodes will be the actual resource where the pods or containers would be running. So using C groups or control groups, you can maintain the resource utilization. What is namespace? Namespace is another part of the Kubernetes where you can just provide or tag a name to any kind of entity in the Kubernetes, like mount namespace, control file access, users. Each namespace has its own set of user IDs. Thus, a user in a higher level namespace can be mapped to another to a lower level. PID, process PID ID in a like user namespace is nested. That is why host can see process running inside of container when inspecting the process list on a system that is running containers. However, inside the namespace, the numbers are different. This means that the first process created inside a PID can be assigned PID 1 and can inherit zombie process if required. Network. A network namespace contains one or more network interfaces. The namespace is on private network. Putting pieces together. So here is a schedule for a typical loop for a Kubernetes, any system or running. So there's a desired state, then there's a controller do some correction, then there's a system, then it's all a system observe the state and observed state, then controller again check the change the state of the system. Kubernetes chooses to model its scheduler as a control loop, so that the system is constantly discovering the current state of the cluster, comparing it to desired state, and then taking actions to reduce the difference between the desired and actual state. This is summarized in the below diagram. Basics of Kubernetes. So, like a group of whales or perhaps a CP pod, a Kubernetes pod is a group of linked containers. So within a pod, you have multiple containers. A pod can be made of one or more containers. Often a pod might be a single container. So pod would be having a web app, 300 proxy cache, etc. Each pod that Kubernetes schedules is allocated its own unique IP address. The network namespace, thus the pod IP address, is shared by each container in the pod. This means that it is convenient to deploy several containers together that is closely collaborate over the network. For example, you might deploy a reverse proxy along a web application to add SSL or caching capabilities to an application that does not natively support them. In the following example, we achieve this by deploying a typical web application server Ruby on Rails alongside a reverse proxy, for example Nginx. This additional container provides further capabilities that might not be provided by native application. This pattern of composing functionality from a smaller isolated means that you are able to reuse components more easily and make it simple to add additional functionalities to existing. This setup is shown in figure diagram. So basically you have one Nginx cache and one web application. Like Ruby on Rails is running on port 3000 and your Nginx application server or event driven server is running alongside in same IP address using port 80 and 443. Kubernetes share the network namespace. So pod will be having unique IP address and the network namespace shared by each container. And you can only expose the port 80 and 443. So suppose you have three containers in a pod. One pod is just pulling some Git repository and sleep for 1 minute, and it is copying that source code into one mounted directory. Then there is a site generator like Jekyll which watches for any changes and then copy this to a www directory that is mounted in a web server Nginx, and only port 80 has been exported. Same thing, you can run some batch jobs, ETL transformation kind of batch or data transfer kind of workloads. Also you can run where run as a data scraper, and then fluent TD which also copy and this to the where run. So some applications scrap web pages, communicate with an instance of fluent TD over a Unix domain socket located in a share. So using a Unix socket can also be shared. This pattern of using a third party is to push data to a backing store not only simply as the implement custom tool but also provides compatibility fluent TD chooses to support. Kubernetes give you some strong guarantees that the containers in your pod have a shared life cycle. This means that when you launch a pod, you can ensure that each container will be scheduled to the same node. This is important because it means that you can deploy on fact that containers in your pod will exist and will be local. Pods are often convenient way to glue different functionalities of several different containers together. Labeling the things. You can also, as mentioned, you can use labels to mention what are the front end application, what are back end application, what you can also key value as a track stable, unstable, beta, etc. You can put labels. Replica set. Replica set is a resource that templates the creation of pods. The definition replica contains a template definition of pod that it creates desired count of replicas, selector of discovery of the pods in this manner. Replica set is used to ensure that the desired number of pod is always running. Because the life of a pod is tied to the it is running and pod can be considered ephemeral. Kubernetes could have evicted the pod to better utilize the resource. Replica set allows us to manage our application by asking the cluster to ensure that correct number of replicas will be running. As a cluster operator, Kubernetes takes some of the complexity of running application away from when I decide that I need 3 instances of. I no longer need to think about underlying infrastructure. I can tell Kubernetes to carry out my wishes. This is the replication control that you have read in older tutorials and documentation. Services, the final basic tool that Kubernetes give us to manage our application services. Services give us a convenient way of accessing our appli services within our cluster. Sometimes often referred to as service discovery. In practice, services allows to define a label selector to refer a group of pods and then map that to something that our application can consume without having to modify to query the Kubernetes together. Typically, a service will provide a stable IP address or DNS name that can be used to access the underlying pod that is referred to as in a round-robin fashion. By using a service, our application don't need to know that they are running on Kubernetes, we just need to configure them correctly. Service provides a way for other applications in the cluster to discover pods that match a particular label selector. It does this by providing a stable IP address and additionally a DNS name. This setup is shown in the following diagram. So basically within a container you have a unique IP address, and for that unique IP address you can provide one name like frontend.local. You can put a label app is equal to frontend, and then all the pods within that container can be accessed like pod 1 and 2. Under the hood we have a master node, then a controller manager, then a scheduler, then an API server, then etcd. What is API server? API server acts as a Kubernetes central hub. All the other components Kubernetes communicate by reading, watching, and updating resources in Kubernetes API. The central component used for access manipulation about the current state of the cluster, allowing Kubernetes to be extended, augmented with new features while still maintaining a high degree of consistency. Kubernetes uses etcd to store the current state of the cluster, and etcd store is used because design means that it is both resistant to failure and a strong guarantee of consistency. However, the different components that make up Kubernetes never directly interact with, instead they communicate with the API, the operator of a cluster, because it allows to restrict access etc only to API server, proving security, simplifying management. While the API server is the component wish to access the update the cluster. Controller manager is the service that runs the core control loops that implement some of the core functionality that makes Kubernetes function. Each of these Kubernetes watches the state of the cluster through the API server and then makes changes to try and move the state to the cluster closer to the desired state. So controller manager is the service that runs the core control loop that watches the state of the cluster through the API and make changes to try and move the cluster to the desired state. Scheduler is perhaps the most single important that makes Kubernetes useful and practical. It watches for new pods in the unscheduled state and then analyzes the state of the cluster's record to running workloads, available resources and other policy based issues. It then decides the best place for that pod to run in. As with the controller manager, a single instance of scheduler works at any one time, but in a high availability configuration, leader election is available. So all these controller, scheduler, API server are available as a single instance and a master and multiple slaves kind of mode in a high availability scenario. Kubelet is an agent that runs on each node and is responsible for launching pods that doesn't directly run containers, but instead controls a runtime such as Docker or RKT. The kubelet watches the API server to discover which pods have been scheduled on the node. The kubelet operates at a level of pod spec, so it only knows how to launch pod. Any of the higher level concepts are implemented by controller ultimately create or destroy pod with their specific configuration. So what is the difference between scheduler and controller manager? Scheduler only works for unscheduled state and then analyze the current state in regard to running available resources, other policy based issues. Kubelet runs inside in each node and it's responsible only for launching the pod using some controlled tools like Docker. So after reading, we know that in Kubernetes, pod is a powerful abstraction built on top of containers. Containers are built on top of lower level features of Linux such as namespace and C groups. Namespace and C groups are Linux kernel feature. So namespaces have four categories, mount namespaces which control access to file system users, what kind of user IDs in the namespace are nested, PID process ID namespace, network namespace, zone private network resource such as address, routing table, etc. C groups are control group of process is the name. They allow the control of several aspects of group of resources. So now we will run how to start a Kubernetes minikube. Build a simple application using Docker container. Use Kubernetes to run simple applications. Minikube is a tool that I have used to run simple Kubernetes cluster in your local laptop or desktop. There are few commands for Kubernetes you can run. Kube, qtl, kube control, kube ct all. Minikube is a command that manages Kubernetes on local system. Windows and Linux, Mac OS doesn't support containers as Linux, so you can run a virtual machine and run some Unix operating system. So for that you can use VirtualBox, VMware, KVM, Hyper-V, all these things that I have already explained in the beginning. For Mac, you can install minikube and kubectl using below commands. Brew install kubectl command, minikube VirtualBox. So using minikube, you can download the image of any Unix operating system. Curl is basically a HTTP command line operation. You can pull any image, then you can change mode to that as a binary to make it executable, then copy these to local bin station. Similarly, in Windows you can run choco command, which you can install minikube and Kubernetes CLI. So these are the commands for minikube: start local Kubernetes, generate, getting VM IP, moving files into cluster, setting up certificates, setting up kube config, etc. To correctly configure the Docker CLI to communicate with Docker daemon inside the minikube, minikube provides a command that will return the environment variable to configure the client minikube Docker environment. On Mac, you can correctly expand these variables. Evaluate Docker version, Docker PS. Building and launching a simple application on minikube. So if your Docker installation is working inside your Kubernetes cluster, you don't need a Docker repository separately. What you can do is You can skip pushing images to Docker repositories, and all you need to is build and tag your images, and then you can refer them by name in your Kubernetes, your resources. So to create a Docker image, you need a Docker file. You put from Nginx, Alpine, and all these. You create a simple HTML. Then you build the application first to ensure that Docker is. You can type Docker build -t hello v Docker run kubectl run this image hello version 1 -image pull policy is equal to never. So that means you don't need to pull this image from the repository. You can directly image is available within Kubernetes, and you can run it. We are setting image pull policy to ensure that Kubernetes uses the local image that we just built. kubectl get pods give you the running pods where state, restart, age, ready state, expose deployment, hello port 80 type, node port. Now you have to expose the ports to access. So port 80 is usually your HTTP application port. You have a label deployment hello. We have set the service type to node port in this case, so that Kubernetes will expose a random port on the Minikube so that we can access our service easily. We'll discuss exposing outside in more detail. When you create a service of the node port type, Kubernetes automatically allocates a port number for the service to be exposed on in multi-node cluster. This port will be opened on every node in the cluster. Since we only have a single node, working out how to access the cluster is a little bit simpler. We need to discover the IP address of the Minikube VM. Luckily, there is a command Minikube IP. It is more than likely that when the Minikube VM started, it was allocated different from your own. So make a note of IP address. kubectl get svc hello. Cluster IP, external IP, port, age is this one. So you can see that Kubernetes export port 80 on our container as port 3266. We should now be able to construct that can visit your browser in case of. So your Minikube IP is 192, and this application Docker image is running inside a container within this cluster, and the node port is exposed to port 80. Then as it is a node port type, then it will map the random port 80 to the outside port, any random port. So container port is 80 and the node port is random node port. So you can access the using IP and this. We have managed to run. So there's a deployment has replica set, how many instances of that application. Then there is a pod will be having some container will be having number of pods. So in this pod, one application is hello, and there's a service that is a node port service which has 32, and it has a run is equal to hello. So this service is hello type service. So deployment is a higher level abstraction that manages the underlying replica set. Advantage of this is that we want to make changes to our rolling out a new configuration to our running application. Now we have to rolling out the changes. So one of the key functions of deployment resources to manage the rollout of new version of, let's look in application. Now earlier we have this application. Now we have used that HTML, we have used just a simple hello world application. And we are using the copy command for index.html to this. Now if suppose we write or update our source code index.h, that is visually we add some things, and then we again create a docker build command to create a version 2 of this image hello, and then we set this kubectl to update the deployment resource to use the new image. So we type kubectl set image deployment hello is colon version 2. Wait for a Kubernetes to launch the new pod and then refresh your browser. You should see your changes. When we update a deployment behind the scene, Kubernetes create a new replica set with the new configuration and handles rolling out the new versions out. Also keep track of the different configurations you have deployed. This also gives you the ability to roll out a deployment back if required. So Kubernetes rollout undo deployment hello. So you can also roll out the previous version. Resilience and scaling. Being able to provide services that are resilient to errors and issues and underlying infrastructure, one of the key reasons why we might want to use Kubernetes to deploy our containerized application. So we type command kubectl get ports, we will get all the running ports. In this case hello, ready, status, running time is 7 minutes on our minikube. Now if we delete any pod, if we then run again the get pods command, we will getting this running 0 restart 08 this one. We notice that the pod we deleted has been replaced by a new pod with the new name. So new name has been created. Kubernetes, we can set the replica set and deployment to ensure that pod instance to run our cluster despite unexpected events if they are failed. So we can also type Kubernetes kubectl scale deployment hello replicas 2. Now if we type, we will see two instances. Minikube dashboard. Minikube also provide you a dashboard. You can see these commands. So Kubernetes has a Kubernetes log command you can type to see the running container logs. You can use tail or logs, any etc log, and you can sh inside the container. Configuration as a code. Throughout this chapter we have interacted Kubernetes with commands. Now kubectl or Kubernetes. In practice I find these tools are useful quickly getting container running. When the Kubernetes become more complex, we deploy some application, we need the configuration as a code. There we actually create a code repositories like YAML or JSON files were there for multiple nodes, clusters, and so if we remove the configuration, this Kubernetes is often referred to as manifest YAML or manifest files. Configuration we created so that we can clean state to reproduce the same kubectl delete deployment hello svc hello service hello. Deployment hello is deleted, service hello is also deleted. Let's define a deployment file. API versions, kind, deployment, metadata, name, spec, replicas, label, application hello, specs, name, containers, name hello, image hello, version with port 80. Apply f deployment or deployment hello created. Now let's do the same for service. API version, name hello, selector, application type, node port, ports, protocol TCP, target port 80. Submit the definition, service hello is created. Now you can see while we have sacrificed the speed running command, we explicitly expressing the sources we want to create. When it comes to updating resource, we can make an edit to the file and then use the kubectl apply command to update the resource. Try editing the image tag in the deployment and then resubmit it to the cluster. we then just making changes to the resources on local cluster. We must have to quickly change something without having to edit the file at all. Previously we can use kubectl setup update a property. Kubernetes doesn't really care how we created the resource use, so everything we did previously is still valid. The other method making quick changes is with the kube command. Assuming you have an editor environment variable set up with your favorite text editor, you open a YAML file, edit it, and then save with similarly update the resource for you. One common problem that you might run when trying to use Minikube is that you might not be able to access the VM because its network overlap with a network configuration on your machine. This often happens using a corporate VPN or your to another network that configures routes for the 192 IP address range used by Minikube by default. It is simple to start Minikube with an alternative CIDR to be used as a you can choose any private range that you want to use. Just check that it won't overlap with the other services on your local network. Minikube start host only CIDR this one. Well done for making this. If you have followed along with the examples, you should very know learning how to manage your own application should be do that. Set up single node Kubernetes, build a simple running a pod, declare Kubernetes, set up services you can access, reach for the cloud. So next chapter we will be reading how to build a Kubernetes cluster that runs on Amazon Web Services from first principles. Learn how Kubernetes works, and we are going to manually launch a EC2 instance. If you have finished with the cluster, terminate the instance. Make sure that EBS volumes have been deleted because you will pay for these storage volumes even if the instance they are attached to have been stopped. This chapter is designed to be learning experience so that through type out the commands you read them. You might have to ebook version of this one. The cluster that we are going to set up is from two EC2 instances, one that will run all the components for the Kubernetes control plane, and another worker node that you can use to run your application. Because we start from scratch, in this chapter we will lay out one method for isolating your Kubernetes in a private network while allowing you easy access to the machines from your own workstations or desktop. So AWS will be having virtual private VPC, and within a VPC you will having two EC2 machines. One is a Bastion host, Elastic Load Balancer, Net Gateway, Public Subnet, and this is a private subnet which is a master node, worker nodes. This is a router which can connect internet gateway which is coming outside the VPC. This is outside world.